Hi everybody, Mr. Vidic here. Today we're starting a new unit on relations and functions. So this is a completely different look than what we did for the last two units. So we're going to get into it fairly easy, okay, nice and slow, and make sure everybody is on the same page with regards to what we did last year in grade 9 and even in grade 7 before that. Okay, so the first thing that you might remember from grade 7 is the Cartesian coordinate system. And this sounds a little bit fancy here. Go ahead and read through this so you get the history of it and how it's worked out. But basically, the Cartesian coordinate system, the way I like to think of it, is it's very similar to a compass. Okay, so if I have north up here, south, east, and west, it's just another way of marking a map. Okay, it is a way for us to locate something. Okay, now the way it works here is that the east here would be corresponding. Obviously, let's just first start at the center here. That's the center. That's the origin. And let me redraw this over here. Okay, so if the center is the origin, okay, and I'm going to go towards east, well, that's going in the x direction, in the positive x direction. If I start at the origin and go left or west, that's going in the negative x direction. If I go up or north, that would be like going in the positive y direction, and then going south would be the same as going in the negative y direction. Okay, so knowing which way you're going is going to help you find points on the map. So let's go ahead and try a few of them. Okay, so it says complete the following by writing the coordinates of the points represented by the letters on the grid. Well, again, if there's a point, every point's going to have an x coordinate and a y coordinate. It's like saying take 3 steps east and then 4 steps north. Okay, well, let's look at a couple of these points. Okay, so point A, that's over here. Okay, so if I start at the origin, I have to take 2 steps east, 1, 2, and then I have to take 1, 2, 3, 4 steps north. Now, using the Cartesian system, I took 2 steps in the positive x direction, so I have to say that. So I'm going to say 2 steps, comma, 4, signaling that I took 4 steps up. Okay, so the way we write the coordinates, we first write the x coordinate and then the y coordinate. Okay, let's go ahead and do B here. B is over here. Okay, B again. Let's do the x one first. So I went 1, 2, 3 steps, but because I went left or west, I have to say -3, because that's the negative x direction. That's the negative y direction. And then because I'm not taking steps north or south, I'm just going to say 0, okay, because I didn't really go up or down. Okay, now let's do C. C's way down here, so let's see how we get there. So 1, 2, 3, 4, 5, 6 steps. 6 steps in the x direction, and then down 1, 2, 3, so -3. Okay, I'm going to go ahead and skip the next two. I think we're all getting the hang of this. Write the coordinates of the point in the... Okay, so we also have quadrants, and this is really important. This is, if we're going to label these quadrants, if I took this whole thing and divided it into 4 shapes, that's the first quadrant, that's the second quadrant, third quadrant, and fourth quadrant. Okay, so write the coordinates of the point in the second quadrant. Well, that's this quadrant. This is the only point in the second quadrant. The coordinates would be -2, comma 3, because I'm going left 2 and up 3. Write the coordinates of the point in the third quadrant. That's this point here. It would be -1, 2, 3, 4, and down 3. negative 3. Okay, now let's look at this table here. So if we had to look at this in quadrant 1, in this quadrant here, okay, the x coordinate is always positive and the y coordinate is always positive. In quadrant 2, the x coordinate is negative, the y coordinate is positive. In quadrant 3, the x coordinate is negative and the y coordinate is negative because you go left and down. Think of left as negative and right as positive, down as negative, and up as positive. In quadrant 4, down here, again, the point, the x coordinate is positive, and the y coordinate is negative. Okay, let's do a couple examples here. So let's look at some patterns with using the Cartesian coordinate system. Our first example says here 3 toothpicks are used to form a triangle. A second triangle is formed by adding 2 more toothpicks. A third triangle is formed by adding another 2 toothpicks. So the first diagram here has 3 toothpicks. The second diagram has 1, 2, 3, 4, 5 toothpicks. 5 toothpicks. This one has 7 toothpicks. This has 1 triangle, 2 triangles, 3 triangles. So for every triangle that we get, we have 2 more toothpicks. Okay, so it says draw the next 2 diagrams. Well, the next 2 diagrams, I'm going to do it over here, would be like this. Okay, and then like this over here. Okay, that would be the next 2 diagrams in the pattern. So that's for this question here. B says complete the table relating the number of toothpicks to the number of triangles. So if the triangles are T, and it says here the first triangle has 3 toothpicks, the second triangle has 5 toothpicks, 3 triangles require 7 toothpicks, 4 requires 9 toothpicks, and 5 requires 11 toothpicks. Okay, so there's a relationship between toothpicks and triangles. Okay, we can all clearly see that, right? The more you need more toothpicks to make more triangles, simple as that. Now let's represent the data from the table, okay, on the grid here. So again, on the x-axis, on the horizontal x-axis, I have the number of triangles. So that's going to be 1 triangle, that's 0 triangles, 2 triangles, 3, 4, 5, and 6 triangles. And on the vertical or y-axis, I'm going to put my my toothpicks, and the toothpicks again would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, so for 1 triangle, I need 3 toothpicks. So that's like saying 1, 3 as the coordinate. Okay. The next one, okay, I have for 2 triangles, I need 5 toothpicks. For 3 triangles, I need 7 toothpicks. 4 triangles, I need 9, and 5 triangles, I need 11. Okay. So this is how I can use the coordinate system to graphically represent my toothpicks here. So it says here, explain for D now, explain why it doesn't make sense to join the points in a straight line. Well, if I were to join the points in a straight line, that would be like saying that every possible value of x, or in this case triangles, would be possible. So if I go between 0 and 1, that is 0.5. This is 1.5. Well, it might at first look like I can get that point, but really, how can you have half a triangle? How can you have 1.5 triangles? A triangle is either a triangle or it's not a triangle. So if I join these dots together, my points together, that would be like saying that I can have, 2.5 triangles. Well, that's not possible, so that's why we don't join the lines here, okay? Don't join the dots, I mean. Describe in words the relationship between the number of toothpicks and the number of triangles, okay? Well, the number of toothpicks increases by 2 for every additional triangle. Okay, so that's what you would put in E. Now, let's write an equation can be used to determine the number of toothpicks if we know the number of triangles. So the number of toothpicks, P for toothpicks, equals, and if we look at our table, we can determine the relationship, and that is if I double the amount of triangles and add 1, it will tell me how many toothpicks I have. For example, 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. So if I double 2 times the number of triangles and add 1, that should give me the number of toothpicks here. This is the most important part of the question, because this formula, okay, this equation allows us to predict any number of toothpicks or any number of triangles. For example, in G here, it says, use the equation to determine the number of toothpicks if there are 27 triangles. Well, if the toothpicks equals 2 times triangles plus 1, well, I'm just going to go 2 times 27 plus 1. Well, that's going to give me 55, I believe, if my math's correct. 55 toothpicks, okay? Working backwards says here for H, use the equation to determine the number of triangles. If you start off with 83 toothpicks, well, same equation, 2t plus 1, but now they're telling us we have 83 toothpicks and we're looking for the number of triangles. So I have to solve for t, and it should be t equals 41. Okay, so what that says is if I have 41 triangles, I will require 83 toothpicks. Okay, the key thing here is that I certainly don't want to draw 41 triangles. It would take me forever. Okay, it would take me forever. So this equation is a nice way of getting the answer fairly quickly. Okay, I want everybody to go ahead and try example number 3 at home. It's very similar. Okay, similar as the one we just did. Okay, except this time we're looking at voltage and current, electricity. So this is going to be useful for if you do physics next year. Okay, so go ahead and do that one at home. And I'm going to just quickly talk about discrete and continuous variables. Okay, so in the previous case, we had toothpicks and triangles as the variables. Okay, but we're going to look at the difference between discrete and continuous variable. Let's look at the definition first, and then we'll talk about it. So, again, the toothpicks example would be discrete for the reason that I mentioned earlier, and that is that you can only have triangles as whole numbers. Okay, so only whole numbers can represent triangles. Where did I go here? Okay, so in other words, I can have 1 or 2 or 3 or 4 or 5 triangles and so on, but I can't have 1 triangles. That just doesn't work. Okay, for a continuous variable, something like the current in the previous example would be a continuous variable, because your variable can take on any possible value between, let's say, 1 and 2. Okay, it can be 1.1, 1.11, 1.112. It can be any possible value. Okay, for example, well, let's look at some examples down here, and hopefully this will make more sense. Classify each of the following variables as discrete or continuous. Time taken to complete a 100-meter sprint. Well, a 100-meter sprint is a continuous variable because for example, if I measure somebody's time, I might get 12 seconds. But if I get a really precise measuring tool, it might be 12.5. If I get an even more precise stopwatch, it might be 12.54, and it might be 12.453, 7, 8. So really, if I had a infinitely precise stopwatch, I can get as many decimal places as I like, and therefore this is a continuous variable because every possible value, you can have decimals, as many decimals as you like in your answer. Basically, the only thing that's limiting you is your stopwatch, how precise it is. Now, let's look at B here. The number of students who passed Math 10, well, that's going to be a discrete variable because, again, okay, if all of you pass Math this year, that's going to be 10 students. If one of you fails, that's going to be 9 students. I certainly can't have 9.5 of you passing and half of you failing, right? That just doesn't work. Okay, so that is a discrete variable because the variable can only take on the integer values. Integer values, meaning there's no decimals or fractions. Heights of students, well, that would be again a continuous variable. It's very similar to the sprint one because if I am 174 centimeters, well, if I had a more precise instrument, I would be 174.5, and if I had a more precise instrument, I would be 174.568 maybe centimeters. So really, my height can take on any value depending on how precise my instrument is. Okay, shoe size, on the other hand, is a discrete variable because when you go to the store, you can buy shoes that are 7 or 7.5 or 8 or 8.5. You certainly can't go to the store and be like, oh, I am shoe size 8.123. Can you please give me that size? They're going to laugh at you, right? So the shoe size is definitely a discrete variable because there's only certain possible values. Now, when I said integer, I guess I was wrong in the previous example because in some cases you are allowed to have decimals. Like in this case, I can have 7 or 7.5 or 7 or 8 or 8.5 as your shoe size. But again, the point here is that they're countable variables. In other words, I can. There's only so many possibilities that I can have. I cannot have anything in between 7 and 7.5. In other words, 7.3 does not work, and therefore because that doesn't work, not all values work. It's a discrete variable. Okay. All right. So hopefully, again, make sure you read all this up here when you're doing this, and you do this one that I left out. I'll check for this next class. Make sure everybody's on the same page here. Okay. Thanks for watching, and see you next time.